Hello everybody, and my name is Tayyip Rashid. I'm the Policy Center, and I'm happy to welcome everybody to our third episode of Smart Edge Talk. And for those who are here for the first time, we started the Smart Edge Talks since last May, and the idea of it was to bring together some sort of thinker, idea generators, initiative implementers to educate us and teach us about, or share with us some of the idea about smart cities. What are the issues of smart cities? What is the technology behind it? What are the data challenges for smart cities? What are the economies? What are the issues related to the governance? So we have successfully running. This is our first episode, and we're continuing with this every month, although we plan to take September as off. And so far, we have had great speakers. And with that, I'm going to introduce our new speaker for today, Mr. Mansour Raad from Esri. And Mansour is a very well-known advocate for big data analysis within Esri and beyond, that all over the world. Everybody speaks very highly of him. His reputation has brought our attention to him.
I think that's much better.
Yeah.
That's better.
Yeah.
Okay. Well, her reputation has brought our attention to bring him and invite him here, and I'm very thankful and grateful for the fact that he accepted our invitation. So I'm going to introduce Mansour. I'm going to let him basically talk about his present his him more if you would like. And so Mansour is going to talk about turning big data into actionable information. And he has over 25 years of experience in the GIS IT field. He's a lead big data subject matter expert at Esri, as a cloud era certified Hadoop developer, image-based specialist. And he has been assessing lots of commercial and government customers, implementing big data to special solutions. And of course, he has been with Esri. He has a master's degree in aerospace engineering from Boston University. And he has actually an amazing blog, and I recommend everybody. I've been following his blog. It's not only big data and technical stuff, it's about several other things. But maybe I think it would be nice if you can go to his blog. This is his blog. That's it. Yeah, then let's go there. Very interesting, very exciting to follow him, and actually, lots of interesting stuff there. So with that, I'll leave the stage to Mansour, and I just ask you to welcome him first. All right? Thank you. Are you loud enough? Or
No, I think I'm loud enough. I think
Okay,
you can hear me in the
yes.
back, right? You can hear me in the back. I think I'm loud enough.
I'll there.
Okay, just in case. Yes, sir.
Will mic quiet?
No, it's okay. I think in the back hear me. Man in the back.
Is it good for the video? Okay. Mansour, don't forget to turn your video on for the video.
Yes, actually, I'm going to turn it when I'm going to do the demo. Okay, fine. Okay, thank you everybody for coming. So again, my name is Mansour. I'm a senior architect at Esri. Actually, we have two hats at Esri. I belong to the professional team, to the professional service team. I go out in the world, like Tariq said, implement big data geospatial solution for the last 4 years. But if some of you guys have used the Esri software here, there's a product back then, long time ago, called ArcIMS. I don't know, anybody use that ArcIMS? Okay, well, guess what? I wrote that. I physically wrote that on a couple of years in Denver. That's why it's so awesome. Then I was involved in Geography Network. I did the Flex API. If you're familiar with the Flex API, I built that. That's literally my silicon. I call these my silicon babies. I have four carbon babies, and I have a couple of. And now this is my third silicon baby that I've been working on. And so for the last couple of years, more than now 4 years, I've been going around the world implementing geospatial big data solutions. What I want to share with you is actually these ideas that I've been doing for government, for agencies, for organizations, and I want to share that experience with you. So, by the way, I want to make this very interactive. If I don't speak London very best, don't tell me to stop, and I can. That was a joke. Come on, please. After lunch, I know everybody's sleeping. Speak London, not English. Okay. So I'll keep my day job.
For my side.
I'll keep my day job. Okay, thank you. I'll keep my day job. And if you have questions, don't hesitate to email me at emrad@esri.com. Again, this is my blog. I blog a lot of stuff on how to do geospatial big data, a lot about it. And of course, you can follow me on Twitter if you want. I tweet some pretty cool stuff, not like I'm sitting on my back eating a peanut butter jam sandwich and stuff like that. So I welcome you to that. So I love this sentence, which actually is a little bit very interesting. It says, where is ubiquitous? And I deeply believe in that. I know it's kind of, it's the same thing, but actually it's the sentence of where that is very important. I mean, we ask where everywhere. Where is the UTM? Where is the closest UTM? Where is the best place to locate a store? Where is UBL? They've been asking about this and they caught him finally. You know, that's very important. Actually, the next one that we've been working a lot on. Where was the next Ebola? And now really Zika. And our folks in the Redlands office and in Miami-Dade have been working very closely with the local agency on helping with these tracking. And we made a beautiful story map. I'm going to show that to you later on these, this outbreak, how we help with the prediction and how it's not yet big data yet, but we potentially could become a big data issue. Right now we're using still traditional ways to do things, but this is a very, very important matter that everybody should be aware of. And literally it comes down to a lot of the things that we wanted to do is to do how to do spatial thinking. And it comes down to mapping, of course, which is very ubiquitous in what we do. Okay, of course, putting dots on the map is very important. But where really spatial thinking comes in is how things are related to each other. And of course, what does that relationship mean? And that's what actually comes down to, it comes really down to what does this relationship mean? And finally, last step, what do you do about it? And so we've been doing a lot of the previous stuff, like, okay, we've been doing pretty good mapping and we've been finding how things are related. It's the last part that actually I've been really interested in very much is what do you do with all these things that you discover? And this is what I've been finding fascinating, and this is the policies that come out of it, and then we know and we execute a lot of these scenarios in here. Okay? And so spatial processing, I want to give you a little bit of history if you don't mind. I know it's a little bit ESRI specific, but actually this is something very interesting if you've been in the industry for quite some time. Actually, history has a way of repeating itself, and it's kind of funny. It is actually repeating itself here, so I want to show you a little bit of what was happening and how it's repeating itself all over again. So basically, back in the 1990s, yeah, I know, not, what is it, 30 years now, you know? We had this ubiquitous format called the shapefile. Everybody's familiar, right, with that file? It's the ubiquitous way of sharing information among each other. And so then took about 5 years, and then the shapefiles were very small. And what we end up coming up is we're coming up with a spatial data engine, something called SDE. ESRI bought SDE back in 95, and actually this is where I joined ESRI. I joined ESRI back in 95. And why I joined ESRI? Because I fell in love with this product called SDE. I was like, wow, this is so cool because we could put data in relational databases. We could put, because shapefiles were kind of limited to 2 gigabyte files and they could not expand very more, and relational databases could hold lots of information and can be very fast, and we can query any attribute we wanted. And the way to do that, we had special APIs to go and put dots on a map, and that was pretty good. So we had always this 3-tier architecture to do things. Then between 1996 and 2005, literally nothing happened for quite some time, which was kind of like, wow, nothing has been going on. And then finally, the relational database vendor says, you know what? We're sick of tired of this middle tier scenario here. What we want to do is we want to bring the spatial engine in our relational databases. So now the Oracles, the SQL servers, the Postgres, and all that stuff started doing these type of analysis in them, and that middle tier totally disappeared. And what you had on the top is these ODBCs and JDBC drivers. Now you can communicate with them, which was pretty cool, and that stays on for a while. And then why this happened is because of spatial indexing. Spatial indexing, they started thinking about it. They started implementing these very specialized techniques on how to break up the world into these little areas, and they could represent that space in databases. Okay, that was really very impressive. I mean, they've been thinking about it for quite some time, but the fact that they can do these kind of things right in their engine become very performant, and of course they have different variation from it, because now they could store point slice and polygons in a very, very effective way and query it and retrieve it very well. There's a derivative of it called the R tree scenario in here. So in the modern day, what happened? Enter the NoSQL. I'm sure, I don't know if you heard about the NoSQL movement. You know, there is this it's kind of like, oh, forget relational databases. We don't need to do any more SQL. And there's this new thing that comes out that says NoSQL. And actually, NoSQL is actually not a negative thing here. It turned out to be actually not only SQL. Not only SQL. So yes, this is very important here. It's not only SQL. And what you're going to end up seeing is SQL actually came back to life, but we want to do it on what we call now unstructured data. And for us in geospatial, the way to unstructured data is to put it in this new format called GeoJSON. It is the most ubiquitous way, again, of sharing information. Why? Because it's pure text. Okay, pure text, people can share, can look at it, humanly debuggable, viewable, okay? And not only, but it contains this complex type of information. If you can figure it out here a little bit, I know I'm showing code, but don't freak out too much. But you can easily read it. It says, okay, there's a type, it's a feature, there's a geometry of type point, and these are the coordinates, this is the latitude and longitude. And oh, by the way, that feature, that point location has a property called name, which is me, and my age is 9. I'm not 99, by the way, okay? Just put it there. But as you can see, it's very easily dissectable, and computers and humans can really read that, and it is a good way of exchanging information. And because of the nested structure, it can hold all this deep information and it can pass it around, which is very nice. So by the way, what's all this do again? And now basically spatial middle tier came back again. So remember, I keep telling you that history repeats itself? And today now, we're starting to do this all over again, ladies and gentlemen. We have now middle tiers, the spatial data engine, not the SDE that we're familiar with, but this new way. But now instead of doing relational databases, it's doing NoSQL, right? And it's talking to NoSQL databases down there. And of course, when we're going to start talking on top, the most ubiquitous way to talk on top is to browsers. Because the best way to push out information is through the HTTP protocol, which is amazing. So now browsers and iPhones and all that stuff can talk to that protocol and can push this information down. Turned out to be pretty good. And suddenly we can now start doing the amazing new things with this new way. But what's old is new again. And hopefully what I predict is going to happen, ladies and gentlemen, is that engine, just like before was there, is going to end up in the next couple of years, it's going to end up down here in these NoSQL engine. And by the way, it's not a couple of years, it's starting to happen right now. We at Esri are building this new thing called the Big Data Store, where actually we're taking advantage of the new SQL engines in here that are starting to do geospatial in them. So again, what's old is new again, and rather than building a bigger ox, well, if you have a cart back in the old days, remember, and you have to pull it, and it gets stuck in mud, you know, you don't get a bigger ox. I mean, you can build your ox so much bigger, so big. Instead, what you do is you bring multiple oxes and put them together, and all these oxes put together, they might not be as big as one big giant one that you invested a lot of time and money in. You can buy all these little oxes, put them together, and they can push that cart out. That analogy is what we're going to be doing in big data. Is we're going to be getting lots of little oxes, put them together, and because they're relatively inexpensive, I can buy a lot of them and put them together, and I can push my big data scenario in here. So as you can tell, I'm a little bit shy when it comes down to telling stories, you know. So I'm going to tell you another story. See, this is my Lebanese ancestry in here. You know, we're Phoenicians, and we tell stories. That's how we propagate things, okay? So I was given about 300 million demographic points. I was working with a customer site. I was given about 300 million demographic data. It's kind of small, actually, compared to today, what we're doing, by the way. So I have gender, income, ethnicity, about 6-7 demographic information. And I was given store location, about 1,000 of these guys. So if I look at it by itself, 300 million data points, 1,000 points, it's not such a big data. But what came down to be very interesting is this. For each store location, for each demographic, I want to create a 50-mile heat map. And what they want to do, this company that I was working with, is when they put the store location, and we create this heat map based on demographic information. If I lay point of sales, I can easily, very quickly, within a blink of an eye, because that's what we do for living very well, ladies and gentlemen, we can pick up patterns very well. I can easily see where my sales are missing, where I need to do targeting. You can see that? So for example, actually it's very interesting because the sales are coming from the area of interest, but for example, they're missing a whole new area that you can really go advertise and target people or something in the territory that they're in. Okay? And by me, when I show this map to a dealer, oh wow, look what else I can do. Look at the kind of stuff that I do. And overlaying this information, I mean, talk about the pictures worth 1,000 words, can really tell what's going on here. And by the application we built for them, talking through all this really brought in a lot of insight and talk about actionable information. There it is right there within 2 minutes. Not even 2 minutes. They look at it and says, this is what I need to target. This is what I need to do advertisement. This is the stuff that I need to do. Talk about big data in action right there. That is one of the applications right there. Beautiful, I love it. So, traditional means for me to do this, using good old-fashioned Python, you see his eyes are crossing. Why? Is because it takes him 14 days of my old friend Python to do what he needed to do, and to process this generates about 850 gigabytes of Rust. Okay. Now remember, they have to do this analysis all the time. And back then, running this taking 14 days, well, unacceptable. I need immediate, information, and things are changing so much that I cannot wait 14 days to do that. So, is there a better way to do this thing? So I was still in Boston when I was doing this. That was about 5 years ago. And I was talking to one of my friends down at MIT. He said, you know what, Mansour, there's this company called Yahoo. Everybody heard of Yahoo. Well, not anymore, okay? Now it's called, what is it called now? Who bought them? Verizon bought them, right? Something like that. I think so. Huh?
I think so.
Yeah, anyway, I'm kidding. So they're like, you know what? There's this company called Yahoo, and they've been using this thing called Hadoop that you really want to check out. Okay, so, so I went and I started looking up and stuff like that. It says that's distributed parallel processing, stuff like that. It says that's awesome. I love this thing. This is so cool. So when can we run this? Turned out that Amazon have bought into Hadoop. So I have Jack's credit card here with me. No, you cannot have it. I know. Yeah, it's right here somewhere. And so I went ahead and I spun up 10 instances. That's amazing, right? You can go up to Amazon, swipe a credit card, and you have 10 instances. I don't have to go talk to my IT guy, procure data, procure hardware, and beg him or her for, and bribe them with chocolate from Belgium when I come back to bring up these instances. I can just take care of my own destiny. And my son, who's now a JV quarterback, says, okay, Dad, take me to practice. Oh, what's that? Came back from practice, something that used to take 14 days, now took 30 minutes. Wow, that was like, for me, this was like, okay, there is something here happening. A lot of boxes that are coming in that are doing stuff for me. So then when I went back, I started modifying with the kernel density values for the hotspot analysis and different values. I remember I had Jack's credit card here. It's gonna kill me. So I went to billing and it turned out to be only like $40, less than $40 to process this whole thing. Where can I do this? Get 10 machines, run this whole thing, try it out up and down. And so for me, this became, okay, I need to really pay attention. Okay, and so actually yesterday, and these prices are now high. This was like 4 years ago. Okay. Yesterday I was in Washington, D.C. working with a customer. We stand up a whole cluster for 4 days, and we would go up and down between 5 people for 4 days, going up and down, trying out different ideas. And at the end of the day, when we shut down to leave, before coming here, I'm like, by the way, how much was the bill? How much was the bill? It was not $20. It was not $20. It was like $19.57, something like that. Literally. I was like, this is amazing. So suddenly, having compute power, storage power, is all available. So which goes back to me now, okay, now that I can do this, what do I do with it? Which is very, very important. Okay? So anyway, so let's keep talking. So, begs a big important question first. What is big data? Okay, so the academics, when you talk to them, they tell you about the 3 V's. Okay, so if you go down to Walmart, if you go down to Best Buy and you buy all the hard drives that they have to hold your data, ladies and gentlemen, you're not in big data space. Okay? You're like, wait a minute. Seriously? Yes, you're not in big data. But it is a relative term. Big data is a relative term. So we keep it in this one, how the academics would like to call it. If the data is coming at you so fast, it's coming at you very fast, and you cannot handle it, you have lots of velocity of data, then you are in big data space. If the data that's coming at you is different, changing all the time, it's not fixed, and you have different formats, healthcare are a prime candidate for that. My blood work is totally different than my EKG, than my brain activity, than where I live. All this talk about healthcare is a great application for a variety of data and velocity and volume. This is what defines big data. And typically you are in one of the edges or in the middle here, bouncing between those guys in. Now I've seen people go crazy with the V's. Okay? They went crazy with the V's. Now they added veracity, and they added validity and visualization, but I'm sticking with the first thing. Okay, this is my definition of big data. If you have too much data coming at you very quickly, and it's so changing every single time, that is a big data, right? And so what creates big data? Big data can be created by people, things, and locations, and I want to talk to you a little bit about it. And for us, one of the things that we're going to be doing is, this is all changing by time. All this information is so temporal. So, and the last one is what we've been doing a lot lately, is space and time. That is so important. So, of course, all of you are familiar with those two animals, right? The Facebooks and the Twitter. 1 billion people, and with the Olympics, they're tweeting information. So talk about volume and talk about velocity. This is a typical representation of the two things, okay, of volume and velocity. Variety is, for example, in the log files. We at Esri love log files. Why? Because log files, because first of all, they're huge, they come at you very fast, and the variety of information. But also, when I look at them, they have explicit and implicit location. What do I mean by that? If I'm tracking a GPS signal, and it has a latitude and longitude, yes, that is an explicit location, I can nail it. But if I look at actually an IP, ladies and gentlemen, an IP for me is actually a location. I can turn that into a location. I can block people from Syria that are coming into from North Korea by IP, of course, if they're not spoofing me through proxy, whatever it is. But I can infer a lot of information. And by the way, we have a lot of criminals that come into us. They're not very smart, a lot of them, that we actually can stop them by the simple thing. It's the smart one, of course. We just have to raise the barrier for this thing. But more importantly, it's the last one that I care about, is the metadata and the information that come along with it. So less than 5% of tweets are geolocatable. So when you come up and you tweet here, you can go to your iPhone application or your Android, and you can literally turn off geolocation. And guess what? Nothing will show up as a geolocation. But suddenly, you tweet, hey, I'm eating a Chicago-style pizza in downtown Indianapolis, right? Okay, so despite that you turned off the tweet, despite you turn off your geolocation, the tweet itself is saying to me, I'm eating a Chicago-style pizza in downtown, what's his name, in downtown Indianapolis. Well, guess what? My NLP, natural language processor, can easily eliminate Chicago as a location, right? And look at downtown Indianapolis, which I can easily reverse locate up and put you down on the map. So you're not going to hide from me. So be careful what you say, okay? Because despite you think that physically you're not trackable, but what you say is trackable. I know, kind of thought-provoking if you think about it, okay? And if we maintain all this information, it is actually kind of scary what can happen. I know I'm going to scare you a lot more when it's going to come down with information. We at the Esri produce 4.7 billion map requests per month, per 3 months. And we cannot draw 4.7 billion dots. But what Jack is interested in, because we have so many geographical information, he's interested in saying where to buy information. We have about plethora of geographical layers that stack up with each other. But Jack wants to concentrate on where to buy the next data. So again, we turn to spatial statistics, and we come up with where people are looking for data. So over the last couple of months here, we can see where people are looking for data, and this is where the area we concentrate. This is a visualization of 4.7 billion map requests. But by us aggregating it and creating a heat map out of it, we come up with statistically significant areas where we want to locate information. So So of course, if you look at the lower left corner, this is Redlands, because of course we're always testing data in 380 New York Street. There's a lot of activities on the East Coast. But notice what's happening here in Northern Europe, in the Netherlands, and in England. Is what's happening is the month before that, the Dutch cadastral just released their brand new data. And what happened is people flocked in and start seeing more information there. And the same thing happened at the Ordnance Survey. They were picking up some very interesting information. People start going down to London and looking at a lot of information around London. So the Dutch cadastral updated their whole scenario, and then Ordnance Survey updated London, which is pretty cool. And of course, I think this is Paris here. A lot of activities in Paris. We see a lot of activities by actually when the meteor struck through Russia a couple of years ago. If you remember, when the meteor came right through Russia, struck right through the atmosphere, we can see the behavior of people coming in and looking at data. Turned out actually this was somebody scraping data. He was going left and right, pulling out tile data, look at information. And this is a violation actually of our licensing agreement. You're not supposed to kind of come in and see. Scraping and pulling data out is actually a violation. And and how we pick this up is by the sequence of data that this person was looking at. And by looking at temporal and spatial data, we can come up with this behavior of what people are doing, and that can become statistically significant and can ring like a bell visually on a map, and we can go in and shut this guy down from taking data. So actually, bad behavior could be detected spatial and temporal. Okay, pretty cool, huh? Anyway, we are 7 billion people on our planet today. 50% of us live in cities today. By the year 2050, which is what for the WHO, the World Health Organization, 70% of us will live in cities. We build these big things like in Burj Khalifa in Abu Dhabi, not because they're very impressive, yes, they are very impressive, but these are the buildings that are going to sustain us in the future. Okay, we're going to be living in these things if we're all going to be. There's so much land that we can live in, okay, if we're going to all live in there. We're going to be living in these big towers. And all these towers are going to be instrumented. Talk about volume, velocity, and variety. Every one of those sensors that are going to be there is going to be pushing these massive amount of data. And they're going to be streaming it in different variety. And they're going to be producing massive amount of data. And just like your sensors right now, I work with Georgia Power, we work with all these companies. They're not anymore picking up, once a day, what is your meter usage. Now it's constantly happening. They're always going to your meter, they're pulling data out, and they're regulating everything that's happening, as you know very well. So talk about volume, velocity, and variety, and this is where these smart cities are going to be starting to get instrumented with all kind of sensors. We're working with the video companies that are looking at traffic, they're inferring traffic from video cameras and giving better redirection and readjusting for traffic based on camera feed. So talk about smartness coming in. Again, it's a double-edged sword. You can use it for both ways depending on how you want to do it. So the common problem that comes in here with big data when you aggregate this is actually what you want to do with it. So a lot of the time that we do is we aggregate and we summarize over time. We come up with recommendations. And the biggest thing for us at the Esri is we come up with statistically significant ways of looking at data. Okay? Because a lot of persons can do what we call a heat map, but we do something we call a hotspot. And there's a big difference for us between a heat map and a hotspot. A heat map is just a bunch of points that are put together and I put a grayscale on top of it and I color code it. But nothing tells me that this happened because of a random event. So you as a decision maker, when you look at these things happening, and I'm going to give you an example out of that, how confident are you that this aggregation of stuff happening is not happening because of randomness? And that is where hotspot analysis comes in to tell you that I am confident that this is 90, 95, 99% not random. And you as a decision maker can take that into account and then go on from there, become smarter. That is the difference between heat map, that, by the way, everybody else can do. When you go to the regular tableaus and stuff like that, you take data and you just throw it in, they can color code the aggregation. Easy, no problem. But are you really going to decide a business or your policy based on just things just aggregating? No. That is very, very important, ladies and gentlemen. Okay? So I want you to think about that. Because actually, I'm going to give you an example. Because me, through maps, I can persuade a decision maker to go one way or another one on how he's going to make it, he or she going to make a decision. Okay, I'm going to give you more examples. So the primary examples that I've been working on a lot with is, of course, telecommunication, telematics, marketing, operational, and of course, smart city goes without saying. Okay? So I'm going to give you examples. We work a lot with telecommunication, back and forth when we look at data inside and outside. They were interested in very much the signal strengths of what's happening, and they've been collecting a lot of data. And one of the main things that they're interested in seeing is where drop calls are happening. Okay? And they want to know it at 10-meter resolution nationwide. And again, when these drop calls are happening, they're interested in seeing the hotspot, not the heat map, because there might be drop calls happening, and they could randomly happen to this, but how statistically significant they are over time. So in telecommunication, we use that a lot to bring that in and visualize and when things start to happen, they can assign crews to the appropriate tower that is dropping calls. And when they overlay it with weather, with social media, with other things, this gives them a better insight of why these things are happening. Okay? Another one that's kind of freaky with this thing is now they're starting to take this information, aggregate it. Why? Because they want to start pushing it out. So there's an internal usage for their own engineering purposes, but these guys now want to start monetizing on it. Freak out example. I don't know nothing about you. I keep phone calls between 9 p.m. and 3 a.m. If I keep that for 6 months, I have a pretty good probability of where you live, likelihood of where you live. I take that, put that on demographic. You're a white female between 25 and 40, okay, and your income is so much. I keep that information between now 9 a.m. and 3 p.m. I tag along that, and I have a pretty good probability of where you work. If I put in I go to my Dun & Bradstreet information, I overlay it on top of it, I have point location, I have a pretty good idea of where you work and most probably what you are. I have a point location where you leave your morning, I have a point location where you go to work. I can use GIS to come up with a route that go along it. I can take all these routes that coming in every single morning, and guess what? I aggregate them together. And I know by 8:30 when you leave your house, you're going to pass that billboard, and knowing how many people you're in, I might push up a certain deodorant. Are you freaked out? This is what happens right now in Times Square. They can aggregate who is actually right now on Times Square. And the billboard that's happening there are not just showing up because they're pretty, they paid a lot of money. They showed up because there's current demographic in that area right now. Now, they don't know who you are, but it's this overlay of GIS information, if you think about it, overlaid on top of each other. It's this fusion that turns it into actionable information. That's what I call actionable information, ladies and gentlemen. Okay? I know. You're like, I'm not going to talk on the phone ever again. Telematics. Telematics is a big one that we've been involved in. Talk about smart city and telematics. And of course, you heard about the guy that yesterday let his Tesla drive him to the hospital because he was having a heart attack. Did you hear about that? Yeah. Between you and me, totally an idiot guy, because guess what? It did not take him all the way to the hospital. He took him all the way to the exit, and he had to take the exit all the way to the hospital. Okay, there was the little differentiator that people don't know is they're not dead totally. It's kind of like the airplane, where the airplane itself can take off and landing, but at the end, when the airplane lands, the pilot has to take over. It's the same thing up today. Well, we're going to come to a point, ladies and gentlemen, where I deeply believe we're going to come to a point where humans are not going to be allowed to drive, because we're going to make too many mistakes. And it's going to happen. I know I love to drive my Corvette, my 1960 Corvette, and I love to do that. But it's going to come a point seriously where I love. But you know what? If you think about it, I don't want my car parked around there. I have 4 children. I have a 17, 16, and a 15, and a 14. Right? 2 of them already driving. Okay, I have extra 2 cars. I'm going to be taking a 3rd car. That's going to cost me lots of money. You know what? And my car that I go to work with is just sitting there in the parking lot doing nothing. Versus I can give it to Caroline, where she can go to school with, or can do whatever it is one. So you see, so why can't this thing take me to work, go back and do something with Caroline or with my wife, whatever it is, and then come back, pick me up?
You're going to let her drive you the Corvette.
Sorry?
You're going to let her drive you the Corvette.
No, you crazy? No, I think that little dinky thing that you're going to let me drive, I'm going to leave my Corvette to me. I'm going to look at it, for pretty and stuff like that. But no, but think about it. You see, I mean, this is where it's a double-edged thing in here. Okay? And these guys are starting to instrument. Every single manufacturer out there is starting to instrument their cars. They're starting to instrument their cars. For internal purposes, there's an internal need for it. And of course, this is going to start communicating with each other. And we're starting working with a lot of them to starting getting information from the road, for smart city doing the road, pushing into them, and then pushing them to each other in such a way that the car that is 1 mile ahead and their wipers are up and going, is telling me, and all the cars in front of it are, what's his name, their wipers going, most likely there's rain, despite that might not have weather information, but the probability that all the wipers in that area are going on is because rain. Push that information back to the cars that are coming in, because I know direction. Hey, by the way, get ready, there's something happening up front. Okay, so this is just an example of what's going on. Or there's traffic, redirect around it, which we've been doing a lot about it, and fusing that smartness of the cities with this kind of information for redirection and stuff like that is happening. And the one that is actually freaky is this one. Insurance as you drive. Okay, no more. You're a 50-year-old man, woman, whatever it is, and your premium is like that. Okay, my 17-year-old, she's been driving now for the last year. Okay, she's been doing awesome. Well, now I go back home to my no, but not that much. She's been doing awesome. Why she should be penalized? Because she's 17, but she's been driving very well, right? Okay, so why can't the insurance company be a good citizen, if you think about it, and promote, you know what, Caitlin, you've been doing so awesome. We're going to reduce to your dad who's paying your insurance premium right now, your rates, and then we're going to keep tap on that one. But you know what? You do something stupid, maybe we'll change. And maybe, hey, you, 50-year-old who never accident, but you always speed by 25-mile school zone, you know what? You're an idiot and you're a risk, and maybe we should do something about that. Okay? So there is that double-edged thingy that comes in, or you speed too much, again, technology is 2 ways and you have to worry about it. But guess what? All of them, every single one of them are doing it right now. So it's not me talking about it, this is what's happening. Okay, I spent a lot of time in Hartford, and name it, they're all going to incentivize you to put this little dongle in the car, and it's going to start collecting, and it's up to you, okay? Right. I told you I'm going to freak you out. Marketing, well, I gave you a beautiful example of marketing that would just happen right now, how they're monetizing on that one. And of course, you can imagine with you guys right now, with the Googles and stuff like that, every time you open up your Facebook or whatever it is, on the right-hand side is the ad for you. Well, guess what? They've been mining all that information about it. And of course, we've been pushing a lot of in the spatial operation, in the dashboard operation for crime. And the last one that we're very, very proud of that we did is in the Boston Marathon. We at the Esri, we tapped on the last Boston Marathon, all the Olympics that's happening. And at the Republican National Convention, we also used the GeoEvent, the GeoEvent processor, to track all the events and we had one common picture to see what was going on in there. I don't think we're partisan to Democratic or Republican. It doesn't matter, but that technology was used to help with the crime scenario in those events in there. And of course, now we start getting data from practically everything. Remember those big cities that I told you about? Those big towers that we talked about, those smart things? Okay, it's because they're going to be fusing all this information together, and they start going to make sense out of it. And we're starting to see a lot of these happening from electricity to sewer to water to roads to in-building happening. It's pretty. It's ubiquitous. Like what I started with the first sentence. It's ubiquitous where all these things are happening. So the biggest thing that comes out from it that I've been seeing a lot is, okay, what do we do with this? It's the derivatives that are most important. And what they've been doing is been taking all this information and funneling it down and producing new information out of it. And it's this new information that is very, very exciting. And of course, for us, we turn it into map and we visualize a lot of that stuff. But again, all these guys are taking this information, turning it into new information, and then pushing it out again. So I see this happening. And now, because we have the compute power, like what I told you, 20 cents on demand, by the way. I don't need to do this all the time. On demand, it will go up, spin it off, come back, and give me back the answer from that scenario. So actually, it comes down to this. This is my preferred definition of big data. Okay? It's not the volume, velocity, and variety, turn out. After all this thing here, is they have a problem to solve. And their traditional means are failing them to solve it. If I give you the example, one of them that we saw that we could have assisted with the Fukushima event that happened in Japan with the earthquake. Remember when the nuclear reactor spilled out its plumes? Okay, the data was not very big coming out of this thing. It was not very fast. It was not very changing. But the window of opportunity to respond to that particular case was so small that they needed non-traditional means to answer the question, should I evacuate this village or should I not evacuate this village? Okay? And that required them to do things differently than they've been doing, because they could not afford to wait an hour to run a kriging in such a way that decide that scenario. Because within an hour, those plumes will reach the people that need to be evacuated at that time. And more importantly, again comes back to the spatial statistics part, which is, how confident are you in telling this village with 10,000 people to evacuate and this village not to evacuate? Right? This is where this big data, spatial statistics, and non-traditional means comes in to do that. Okay? So, for me, the definition of big data is this. When traditional means are failing you, so it becomes a very relative issue, then you need other tools to do that. And you've exhausted all the tools to do that, that's when we come in to do that. Okay? So what are the new means? So, first one, that is the most ubiquitous way, okay, and I've been doing this a lot, is this guy called Hadoop. Okay? So we talked about that before. So Hadoop actually came from a paper by Google. So Google, how do they store all this information in there? They store it in something called the Google file system. And actually they put out the paper about it and how to store on cheap, inexpensive hardware that information. So again, it goes back to my story. How do I get it on $20? Is because guess what? They're not using custom hardware for this. They're going out and getting cheap and expensive hardware and getting, remember the aux story? Lots of auxes, lots of cheap stuff putting together, and using that, let the software take care of resiliency. They can now scale and hold petabyte of data. Okay, so again, that's the real thing behind this whole thing. So when the paper came out, the open source community says, you know what? We are going to take this, we're going to read this, and we're going to implement it. So that's the first thing that came out of it is the Google file system, which is the Hadoop, one of the first projects of Hadoop. Okay, so by the way, when you go out and people talk to you about big data and they mention the word Hadoop, that's what they're talking about. And by the way, it's made up of multiple things. It's not just one thing. It's several components in a stack. So Hadoop is a stack of technologies where at the bowels of it is how to deal with massive spatial, how to deal with massive information and being stored on cheap and expensive hardware. Okay? So that's what the first thing is. So this is literally what it is. That's what it literally looks like. Cheap and expensive hardware down and below. And on top of it is a file system called the HDFS, the Hadoop file system. And literally the resiliency of these hardware is done by software, where this layer sits on top of it and monitors all these things. If one of those machines goes down, no problem, I can replace it, and you'll see why a little bit. Then on top of it is these other animals that come in, it's like yarn and MapReduce that sits on top of it. So this is the basic stack, and this is what basically at the fundamental Facebook and Google and stuff like that runs by. This is the stack that they use. And of course, there's more animals in the zoo. Actually, it's called the zoo is because guess what? They have all these animals. They have pigs and hives and sharks and impalas and there's a zookeeper on top of it to maintain state from the whole thing. Okay, so they literally call it the zoo. I call it literally the zoo because of all these animals. So this is when somebody comes to you and says, what is Hadoop? It's this stack in here, and this is what a lot of people use to do a lot of their processing in here. And so how do you manage this big data is literally you have dumb drives down at the edges, by the way. Okay? So literally there is an intern at Google that literally his job or her job is to literally go around replacing disks. Because every 10,000 machine you have, every day one of those machines are gonna fail. Okay, so imagine if you had gonna be filling this room with disk drives. By the way, ladies and gentlemen, guess how much is this? This is 1 terabyte. This is 1 terabyte. 1 terabyte. So imagine a room filled of these. Okay? And they have more than that in a lot of places. So if you want to manage a lot of these, they're going to fail every once in a while. Fail. So how do we take care of this? We put one of these here. And then we have software that deals with on top of it. And there's a leader that manages all that information. Every piece of information is replicated on every one of those for resilience. Now this data is so big that you cannot bring the data to your program. What do I mean by that? When you open up your Excel spreadsheet, what happens? You take your Excel file, you load it into Excel, you operate on it, and then you save it back down, right? Okay, that's fine if you have 1 megabyte or 2 megabytes. What if you have terabytes of data? You cannot bring your data to your program. So what you have to do is you have to do things totally different. You have to take the program and send it to the data. That is that paradigm shift that you have to start thinking about. So these new animals that we deal with, they do that. And they do that using this thing called MapReduce, where they can take much of data, map it to something else, and then they reduce it. And these two tasks can be done all in parallel, which is pretty amazing when you think about that. So our job at the Esri is to take this animal here and to basically pass it. I love this other sentence here by Richard Werman. You can only understand something when we start processing this when you compare it to something you already understand. This is the foundation for a lot of things that we do at Esri. And we as humans, if we compare things exactly the same with something that we already understand, we can see the relationship in the other one. And we use that for deconstructing, telling stories like what we always do, and to visualize. So, one of the very important information which I've been always talking about, when I want to fuse information and compare it, okay, we use spatial statistics. So let's take, for example, the drought in the United States that happened, the drought intensity. And I want to see how unemployment is being affected by drought. This is two things that we put together that we always correlate, and we want to do correlation. This is the same resulting information, but color-coded totally differently. And I can persuade a decision maker to allocate money to a different region by taking the same information, by color-coding it in one way or another. Same information, just color-coded differently. Okay? And kind of powerful if you think about it, how much the power of maps is. Okay? Just same information, just color-coded differently. And so, to really take care of the subjectivity of this, we apply statistics. That's why you have to stay in school, kids, okay? Because you have to understand what this math means. So when Connor My number two comes up to me and says, why I have to learn this, Dad? Is because I tell him, you like your, what's his name? You like your Nike Jordan, right, son? And for Dad to pay for this, he understood this. So stay in school, learn it, so like that you pay for your own son your Nike shoes, okay? So moral of the lesson, stay in school, okay? Understand what this means and turn it into statistics. Okay? And then when we take that and we apply it, now we see how geography, how we're statistically significant, the hotspot that are being affected, the unemployment that is affected by drought. Okay, and when we overlay it, we come up with beautiful information as maps, which is very, very powerful. Okay, cool. And now imagine doing this on billions and billions of records and coming up with these answers very quickly to really give you the information that you need. Okay, so I'm going to take a small break here. We talked about big data. We talked about some of it a little bit. I touched a little bit on the technologies here, and to give you a little bit of stories of what we want to talk about. So I'd like to take a small little break here, and then let everybody talk about it, have questions, and then I have more stuff to talk about. Okay? Any questions?
I just have a comment. You just made this incredibly easy to understand. And it kind of scares me a little that I actually think I understand.
Well,
I mean, it's just, you hear so much about this, but I've never heard of the concepts.
Well, good. I'm glad.
Okay.
Thank you. Thank you. Thank you. Well, good. I'm glad you like it. So, yeah, so any question? Yes, sir.
I've been working a bit more in the open source realm with setting up a GeoMesa stack for big data.
Yep.
And so I've ran into some problems in getting everything set up. So I'm curious what Esri has in line to help us surmount that stack challenge.
I'm going to talk about it at the end, but we're very, very familiar with GeoMesa.
Okay.
I work with it with 3 different government agencies. Actually, last week I was in San Diego working with the Navy on exactly that
So
same project.
CCRI.
Yes, the Spaywall folks down there, yes. But we were literally in San Diego for 2 days, we talked about that, we showcased how to connect GeoMesa to ArcGIS. We're very proud of that effort, and I can talk to you more about that.
Yeah, because I'd be curious.
Yeah. So we married the two together. So despite that we ASRI are very, relatively closed format, but we do believe and we do know that there is a world out there with other things. And so rather than no, we're more open. I was telling Jim here at lunch, we do think of ourselves at the center of the universe. We're the sun and everybody above us. But when we go physically out there, we are actually not even a planet. We're Pluto, and they are the customers, and we revolve around them. So we're very aware of this, and we want to play nice. Yeah, definitely. Because, like, for example, your domain, if you play with, there's billions of records already in there. I'm not going to tell them to come in and modify it to my need, but I want them to play with me. Yes. Okay, I'll tell, there's more coming at the end that I'm going to tell you what our road ahead is. Okay. Any questions, ladies and gentlemen? Or I did such an amazing job that you're floored that you have nothing. I answered all your questions. And I'm so modest about it that you guys like, forget it. Yes.
So who is out there mining social media information now?
Literally, practically everybody. Literally everybody. Every person I go to, the first question they go in, besides taking their own data, the next question is, how do I fuse external data? And they look at, the first one, of course, is the Twitter, because they have the firehose that you can subscribe to. If you go to like this company, actually there's a company called Ganip that was bought out by Twitter. And they used to give you a firehose to all these social media, to the Yelps, to the Facebooks, to the check-in, to the Foursquare check-in, all that stuff. They would just, you just buy subscription, and you can get access to all this data.
Are they able to harvest the implicit location?
Yes, and that's what they do. A lot of them, that's what I was telling you, like that implicit thing, like I was telling you, I'm eating a Chicago-style pizza in downtown Indianapolis. Yes, they are doing the NLPs on it. Yeah. to really get that info, to get the derivatives. You remember I keep telling you derivatives? To get the derivatives. And then they fuse it with other information. And now a lot of them are starting to realize that geospatial is very, very important. And they look up and they're like, wait a minute, there is, my tax dollar was paying for the Census Bureau, and there's all these title files that are available and all these other demographic information. I can get some of this for free. And oh, by the way, no, this is not good enough. I need to go to Dun & Bradstreet. I need to pay Dun & Bradstreet to get this other, this other data that, well, okay, this is more detailed. Like there was this some data set that we're working with has 17,000 variables. I know per demographic how many lawnmowers were bought on a particular lot level. Really? But yes, there is somebody out there that needs to know how many lawnmowers were sold at that level. Okay, fine, use it. This is a variable that you're going to put into your model to do your regression, your classifications, and stuff like that. And then we haven't talked yet about machine learning yet. This is where I'm sure you've been hearing a lot about machine learning, right? If you haven't, then this is how, this is what all the cars are driving about. This is how the latest Google Go, that's how they're detecting cats in your photos that you're uploading, by the way, among many things. So we're pushing that angle too. Actually, last week when I was in Washington working, we're trying to predict deforestation. We're trying to predict deforestation. We have literally 30 meter by 30 meter worldwide what is happening. 30 meters, ladies and gentlemen, resolution. Okay? It's about 806 billion record. No problem. Spin up a couple of Amazon instances, shaka boom. All right, shall we keep going, ladies and gentlemen? Okay, let's go. Okay, so we're at the break. That was the break. So I wanted to talk to you about actually, why don't I want to keep going here. I want to show you something that we're working on that might be a little bit more relevant to you guys, and then I'm going to come back. So I have a couple of videos here that I'd like to share with you guys. One of them is the Insight. Has anybody been to our user conference? Yeah, have you seen this? Okay. Okay.
Insights is a new web application and experience which allows you to do exploratory and interactive spatial analysis with your data. Let's focus on some crimes from Philadelphia and use Insights to explore 2 years' worth of data. In Insights, your data is visualized in multiple ways, on cards. All the attributes are exposed, so you work directly with that data. Your data can be visualized as maps, charts, or tables. The legend is completely dynamic, so you can select out your data and see it being reflected on the map. You'll also notice that all the cards are linked, so everything is interactive. I can select by type of crime, by year, and you'll notice that my map is updating, so now I can also see the spatial pattern at the same time. You can bring into your data onto any page from multiple different sources. For example, you can add your data from your organizational account, from Excel, and this can have multiple sheets, and also from databases, such as SQL databases. Data can be spatial or non-spatial. Sometimes you can geocode that data, or you can just start to work with that immediately. You can work with your non-spatial data and spatial data together. You can work with it as tables or even as charts. So now we can see the total number of crimes showing the percentage change between 2014 and 2015. And we see that overall, in the city of Philadelphia, crime's been decreasing. They've only seen a small increase in the number of thefts. Different visualizations allow you to see your data in different ways. And you can change your visualizations with a single click. So I can go from my map to a bubble chart, or even to a tree map, where I can clearly see which crimes are the most common. And of course, I can always change back to my map. On the back of the card, we report the summary statistics. I'm working in a browser, but I can still work with large data. I'm working with over 125,000 incidents in this data set. So let's focus in and look at the data in more detail rather than looking at the overall patterns for the city. Spatial analysis is very much a key part of insights, and this can be done through drop zones or even by using the Action button, where all our spatial tools are exposed. So let's aggregate the number of burglaries into my police service areas. Doing a spatial aggregation is as simple as taking the information from one card and dragging it into the other. And if I did that too quickly, everything I do in Insights, everything you do in Insights, you can undo and you can redo every action. So you see, a polygon overlay really is as simple as just overlaying that polygon. All the values at each location are reported, but in context of your data. So you see it with the minimum, the maximum, the mean, to help you understand that data clearly. And as I've already shown, on the back of the card, your summary statistics are reported, this time for the aggregated data set that we've created. The data you create from your spatial analysis can be directly interrogated. So now I can look at the total number of crimes by each one of my service areas. So repeating that analysis across my 2 years of data from 2014 and 2015 and placing my cards side by side, I can now quickly pick out areas where in fact we have seen an increase in the number of burglaries. But totals don't tell the whole story, and often we need to normalize our data to take into account the number of people who've been impacted. I can do that very easily in my data table by doing a field calculation. So having calculated those rates, I can change my data type to being a rate. And now, as I drag that variable across, you'll see it's correctly visualized as a choropleth. So do my rates increase in the same way as total number of crimes? Visualizing them in a scatter plot, we can see if those two variables increase in the same way. We see that there is a relationship, but when I put on the line of best fit, it's a very weak relationship. The spatial resolution in our data can sometimes hide the patterns that we're looking for. And in Insights, it's very easy to explore your data at a different spatial resolution. So let's have a look at one particular area in detail. So how am I going to select out an area of interest? That's right, I'm going to take the polygon from that area, and I'm going to drag it over to my other card, and now you'll see it's filtered out that area. So now I can re-aggregate that data. This time I'm going to look at it by block group level and try and understand the distribution in that data set. By using the Action button and changing my tab to Find Answers, I'm now given some helpful suggestions, rather than the spatial analysis tools, as to how I can get more from that data. So I want to understand how it's distributed, and I'm going to use a histogram. So this has been the total number of crimes I've got in each one of my areas, and by selecting on the graph, I can quickly see reflected those areas where I have high numbers of crimes or low numbers of crimes. So through this quick exploratory analysis, we've managed to gain some insight into crimes in Philadelphia. But there's just one more feature that I'd really like to share with you. Throughout my whole analysis, everything I've done has been recorded. So I can rerun that workflow. You can rerun your own workflows, and you can share those workflows with others so that they can rerun the same analysis but using their own data.
So that was insight that I want to share with you guys. Is basically a way for us to, it's kind of our answer to the tableaus, if you think about it, and the clicks, is to really quickly, for you guys that know nothing about big data and geospatial and stuff like that, literally have this drag and drop way of interacting and exploring data and to try out different ideas. And if you have these different indicators, like what we always talk about, all these layers on top of each other, it's so easy to now literally, like what you saw, be able to drag and drop and try out these ideas, and all these statistics, these statistical significance are showing up and coming up to you. Pretty cool, isn't it? Yeah, pretty neat. I think you guys can try it out. And
I'm surprised nobody clapped their hands.
Well, I have one more video to show you guys, and I wanna talk some more about a couple of more use cases that are kind of cities, if you guys don't mind. Another one. Okay, so we talked about a lot of targeting, and actually this we did with the targeting with social media. We did for a lot of affiliate government agencies, where we were looking at social media and aggregating billions and billions of records. Actually, I'm going to show you a video of that one here. I'm going to jump into this one, the city of Rotterdam, and this is where actually the definition of traditional means failing, and you needed another way to deal with things. So Rotterdam, the harbor of Rotterdam tracks ships in and out of the harbor. It's the 8th largest harbor in the world, after the first 7 are all in China, by the way. It's the biggest one in Europe, by the way. Very interesting statistics. I mean, China is so big and so powerful and stuff like that right now that literally the first 7 harbors are in China, and then this one comes in after that. But it's literally a whole city. It takes about 4 hours to traverse the harbor from one place to another one on a boat. But it's so big. It's about 40 kilometers big. And if you're on a boat, it takes forever to go from one place to another one. And they are interested in looking at everything that's going in and out of the harbor. And so one of the criteria when we come in, we were working on this project. It was very interesting. It was November. It was November, right? No, what's before November? September, October. It was October. So it's almost coming to the end of the year, and everything is good. Life was happy, and then they're like, "Hey, by the way, the contract says here that you have to hold all the AIS ships movement in and out of the harbor for the last 5 years, online, available all the time." Okay. So that was October, and they just found this out in first week of November, and they're like, "No problem, we can take care of this. Let's go talk to our database vendor." So they went, they talked to the traditional database vendor, and the traditional database vendor came to them and says, "No problem. We can meet that SLA of yours by the end of the year, which is January 1st, if you give us X million dollars." Talk about traditional means failing. They're like, "Wait a minute. First of all, we deeply believe you guys are taking advantage of us, right? 2, we're out of budget. We cannot pay that dollar amount that you're asking us for. And that means we're going to be in breach of our contract. We literally need something differently to do something." So the data actually, it's only about 6 terabytes of data between you and me, okay? It's not very big, okay? And it's not coming very fast. I mean, the ship movement are only about 10 seconds the frequency of ship movements, and it doesn't change very much. The AIS ship information is not very big. I mean, it's fairly constant what ship traverses. But it's that last thing that they had to meet an SLA within a certain time frame that they could not deliver it. So it's not about volume, it's not velocity, it's not variety, but they could not economically meet it within the traditional means that they have. And they did differently. So literally they called me up, they're like, "Mansour, you've been talking about this whole thing. Can you really do it?" And I'm like, "Yes, I can." And literally got on a plane, drove up flew to Amsterdam, then took the train to Rotterdam, and literally walked in. I'm like, "Okay, I'm here." They're like, "What do you need?" I'm like, "I need machines." They're like, "Well, we need to talk to the procurement guys." And I'm like, well, can we start up Amazon? And the security officer was like, no way. We're not, and this was back then when, this whole thing about putting data up in the cloud, and no, it has to be, if I have to do it, it has to be in the European, because we don't trust you Americans. I'm like, whatever, go away, I don't care. Okay, and they're like, no, we need to do it here. We need to do it on-prem. So I literally looked around, I was in their offices, literally looked around, and on the floor, in the corner, there were literally these Dell blades stacked up, sitting there, literally collecting dust. So I'm like, I need those. They're like, but they're out of warranty. I'm like, I don't care. That's exactly what I need. I need cheap and expensive hardware. Like literally what I've been preaching. Cheap and expensive hardware. He says, okay, take those. So literally we dusted them out. It was Thursday. We dusted them out. So by Thursday afternoon, we put them in the rack. We had all of them up 6 machines. So each one of them has 1 terabyte. So I had 6 terabyte that can hold it. Took all afternoon to bulk load all the data. Then, like typically happens all over the place. This is what you need. It says, I need the data now. We need to start bulk loading. And literally what happened, they give me literally physically USB drives. They're like, okay, here's the data. Okay, do something with it. That happened. You think that this happens this one place? This happens all over the place. People, traditional means are failing them. Their SQL servers, their own stuff like that. Guess what they do? They take their data out, they put it on USB, and this is one day we're gonna use it. Guess what? Never happens. I actually have a blog post that titled USB data goes to die on USB. Truly, that's what happens. Literally, you think that your data, you think that you're going to use your data, that you're going to come back to it. You never ever do anything with it. You take it out, you put it on USB drive, you shelf it, and that's it. And your boss comes to you and says, I want to analyze a year's worth of data. You tell them, no, I can't because the data is on USB. I need to bring it back in. Well, what it takes? Well, I can't. Traditional means are failing, and you need a new way. So he literally handed me, I don't know how many USB drives, okay? So spend the weekend, guess what? There's no data science. I'm not a data science. Guess what I am? I'm a data janitor, okay? Because that's what I do. I literally clean data and shove data around, that's it. So spend the weekend bulk loading data into the HDFS, and by Monday we had literally the whole 6 terabyte ready to go. And then we start working on the data finally itself to get the insight that we need. So we did the whole presentation about it at the port of Rotterdam, and it was pretty good. In Brussels, my friend and I, and was pretty good. And literally came down to help the port be smarter. I mean, the whole port, if you think about it, is a city. I mean, it's so big and so it has the same problem as a city. There's network, there's congestion, there is pollution, there's all kind of things. It's a whole city if you think about it. So they want to be smarter, faster, sustainable to be able to do whatever they want with it. So what we did is we built a full-fledged application to access any piece of information that they want within toolbox. We have toolboxes that you bring up. Enter the information. I call these PhD forms, push here, dear form. The user does not know anything. He or she does not know there's a big fat cluster running in the background. Just pushes numbers, and this thing goes out, crunch, 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 and gives them back the answer that they needed, which was pretty cool. Okay? And so we end up working all kind of analytics and stuff like that. It was pretty cool. And so this we finished in 3 weeks. So that was Thanksgiving, right? So right before I was going to go to Thanksgiving, they're like, okay, Mansour, you did such a good job. Why don't we take you on the harbor? I'm going to give you a tour for the harbor. So we went to tour of the harbor, and then we went to the harbor master. We went up to the harbor master. On the wall of the harbor master in 2015, there was a big, big map. And on the map, in 2014, ladies and gentlemen, the digital map, there's a grease pen right next to it, and there's circle areas around it. Okay? Talk about, kind of the stories between the two. I'm like, what are these? It says, these are my dredging prioritization area. I'm like, what do you mean? It says, well, sediments get flown into the harbor all the time, and they need to be dredged out. So like that ships, when they come in, they don't scrape the bottom of the harbor. It says, well, how do you know this? It says, well, we have, we kind of know, we sound the harbor every single day, and I know what's the depth of it. So literally every morning, there's these ships that go out and sound the harbor at 1 meter resolution. So you can imagine a 40-kilometer harbor, how much data they're producing. So I'm like, that we can produce those maps automatically for you. But he's like, what do you mean? He says, well, give me your 1 meter resolution every single day that you produce. Like, yeah? He's like, I know the ship's movement in and out of the harbor. I know what every ship is, and I know its draft. So if I take every location, I know the depth, I know the draft, I can easily calculate delta. Again, stay in school, kids. Big D minus small d, okay? Not very hard to figure out. Okay, so where is delta t becoming zero? It becomes literally nothing but just running this in parallel on all 1 meter resolution across all the harbor, cross-referencing with all the ships that are going in and out. And when we finished it, we come up with these beautiful, actionable information maps that really tells him this is where you need to go dredge the harbor in such a way that's where things been gonna scraping and you need to go out and dredge. Again, turning big data into actionable information. Pretty cool, huh? Okay, that makes sense, and it's beautiful. I love those hexagons. Okay, I think this is what I've been loved lately with this, all these hexagonal representation, this aggregation. They really, really produce this really beautiful visualization. I call this expressive mapping. I call these expressive mapping, which is pretty neat. Okay. So we did. I have a demo of Abu Dhabi, by the way. I'm gonna show a quick demo. Also, what we did. So I have actually on Amazon right now. I started up a whole cluster where I bulk loaded on my EC2 instance. So, by the way, literally I did that this morning. I have this big fat instance running here. I loaded about on it. It's one single node cluster, if you guys can see it. I loaded about 2 million records of New York City taxi data. Okay, and so what I want to show you, one of the things that I always get is how do you interact with this data. And so I have this toolbox. This is exactly kind of like the same scenario that we did at the harbor, where we can go in. So this is our GIS. And in our GIS, in the toolbox in here, one of the things that we can do is we can basically have these toolboxes. And these toolboxes, by the way, FYI, if you're a geek, they're all written in Python. Okay, so one of the things that I would highly recommend, if there's a language that you guys want to invest in big data and stuff like that, is really start investing in Python. It's the most ubiquitous way to actually get information in and out, and the extension of course, a lot of the platforms out there. I'm sure some of the other folks come here and talk to you guys about. So this toolbox enables me to actually go in and query this Amazon instance where I've uploaded the 2 million records in here, and we can basically go out and now within the new big data store, I just queried 2 million records in 3.2 seconds, downloaded all the data, and visualized it on maps. Again, this cannot be done in regular relational databases, by the way, ladies and gentlemen. This is where the NoSQL engines are coming in to help me out with this map. So again, no traditional stores where I'm storing this, highly indexed, but I can go out, query this thing, and come back. Pretty cool, pretty expressive, pretty powerful. And I can come in, and of course, this is not pre-aggregated. I can go in and ask it for, give me, there's a field, P date, the pickup date, HH, I wanted to see what's happening at 5 o'clock in the morning. So this goes out, aggregates, I love it. Okay, and I can, of course, take advantage of the beautiful symbolization that we have to come up and do these beautiful things. And of course, all the 5 o'clock pickup are not in the main area. This is the central station, where Penn Station, where you can do these really nice things. And of course, nothing is happening in LaGuardia at 5 o'clock yet, okay, which is right here. And of course, not a lot of traffic from JFK. Good, cool. Anyway, some of the analytics that I wanted to show you guys that we can do right now with the new. Actually, this is the big data store that we're promoting, and it's the new stuff that actually you don't have to have the RGS platform. This is a new way of storing data, highly indexed, very, very quickly searchable, and you can insert it right on demand to the whole thing. Any questions, ladies and gentlemen, before I proceed? So, by the way, they saw me do this in Abu Dhabi. And they're like, okay, we want to do the same thing. Practically every city in the world right now, talk about smart city, every city start aggregating data from all kind of places, not just from their infrastructure, but from also what's happening on it. So in their particular case, same thing, they started collecting taxi data. And so they literally, all the meters now that they have are all aggregated, and they go to a central clearinghouse, and then they're pushed out. And so they literally, just like them, Here you go, Mansour. Here's a CSV file on USB drive, 315 million records. And we use this technology called Spark. I'm sure you heard about it. It's basically the new MapReduce to do massive parallel. And we're storing it in a no big data store, which is called Elastic, in order to store all this thing. And again, only 4 CPU, 12 gigabyte of RAM, 256 disk drives, nothing, but we can spin off these things, no problem. Literally, we started 4 of these guys on that infrastructure, on a VM, and we were able to be up and running. And then through Python, like what you saw, we were able to aggregate, visualize, and display on these dashboards, on desktop and on mobile devices. And of course, we can visualize it pure textural, but of course, the maps makes it so expressive. And again, just like the other guys, we wanted toolboxes within a couple of minutes, just 300 million records actually on that cluster. Look at this. 1.2 seconds to aggregate 315 million records. Yeah, it's pretty cool. And of course, all the aggregation is happening right there. And guess what these are? These are the malls on Friday afternoon. People go to malls and they get picked up from malls, which makes perfect sense. Of course, they do it, but kind of visualize it and see it kind of makes it more realistic. Yes,
Tarek. Maybe a unique question, but so what's the implication of this traditional way of looking at the database design? That usually we talk about, like, when you think about data for local government and smart cities, it's still on the traditional way of designing geographic model or with this kind of like new approach and whatever Esri is going for this new data store, what does it mean for us to design database? Just profile together in areas and just launch the...
Very important, very good question. Very, very good question you brought up in this discussion here actually. This is the concept of data lakes. You've heard of this thing called data lakes? I don't know if you heard about it, but this is something that you're going to be hearing a lot. Data lakes. And unfortunately, these data lakes are going to become data swamps. Why? Because through the HDFS and these big data stores, you can store so much data that will end up getting lost. And the worst part, nobody has a metadata or a cataloging on top of that. So, yes, I can store massive amount of data on these things, and yes, I can index them, but the problem is discovery of them and legacy and what's his name, and lineage of these things is so important. And that gets lost in a lot of these new places. So one of the things that, yes, we are advocating those new data store, but we're advocating them not by themselves. We're advocating them by you putting like a geoportal or like a catalog on top of it to really make sense. And this is where, again, I know I'm putting my Esri hat in here. This is where the portal story comes in to help out with the discovery, the visualization, the cataloging in such a way that you can disseminate it better. So it is something that we're seeing a lot. We're advocating it, but the problem is if you do it halfway, you'll end up losing because you can put so much stuff, you don't see anything out of it. So I'm always advocating that, plus a catalog that comes along with it, a cataloging engine that goes along with it, in such a way that whatever you put in there, you catalog it, you see it, you have a reference to it, and anybody can discover it, and you can execute stuff on it. So from a spatial data infrastructure, if you think about it, yes, it is not a replacement, very important. It's not a replacement, it's a complementary. Okay, so we go, like at the harbor, for example, at Rotterdam, we did not throw their existing infrastructure. We complemented it. We complemented it with this new way, And they end up coming up with something we call multi-temperature environment. And what do I mean by that is you have now hot data through this, like for example, this Elastic. You have warm data that you can put through HDFS. And now people are taking advantage of the cloud to take data that is beyond their SLA and put it in like something like an Amazon glacier. When it's still available, but it's cold, it's deeply cold to be retrieved. And so it's this multi-temperature SDI, spatial data infrastructure, that is coming to help. And you use, and the trick is, it's not one tool, unfortunately, that can do everything for you. So now what we're seeing, and what we're advocating, is different components to do different thing part of your spatial data infrastructure. And so we see hard data sitting in something like Elastic that is highly indexed, but it's only sitting within the SLA that I need to meet my on-demand quick query. You see something like HDFS, cheap and expensive magnetic, like for example, Elastic is sitting on 32 gigabyte of RAM SSDs. Okay, those are actually become a little bit expensive machines. But I'm not going to have a lot of those because they're only going to hold, for argument's sake, 10 days worth of data. Okay, depending on what I need. Then I have these magnetic guys, which is HDFS sitting there, that is still available. That's still available. But these are, I'm willing to wait a little bit to get to them. And then you have the final one that beyond your SLA, like the 5 years at Rotterdam, I'll take those out and put them up in Glacier, which is cheap storage. But you know what? I literally need to bring them in to be able to do whatever it is I want. So it's not one animal only now. It's multiple animals with all the love and affection to each one of those pieces. You see? And that is what we've been advocating. And actually, that's what a lot of people have been doing.
Actually, a great lesson for us.
Yeah.
To have like data and all of
right. So
as well, big data, what happens to the whole data?
Exactly. So this is why people pick up stuff like what I was telling you. Okay, is they decide where things are going to go, and they have these protocols on where they move from hot to warm to cold. Okay? It's very important, and we've been seeing this happening more and more. And again, like what I've been saying, it's not one thing only that is for everything. We're literally using the right tool for the right job. Okay? And I can go do hot data on a relational database, but it's going to cost me a lot of money just to satisfy their engine demand. Versus if I switch to something else, to a different engine, I can get cheaper hardware and even beat whatever their expectation is.
And this is for the economics, so I'm talking about also the way of organizing the data.
Right, so that's another thing. Yes, so that's one thing. Now comes in, that's the problem here. This is your data lake. The problem is it becomes immediately a swamp. Within 2 minutes. I mean, once we start, I can fill up, if I'm streaming data from a GPS feed, I can easily fill up a 2 gigabyte data within I can fill up a whole database in like literally a couple of hours. Okay? And so suddenly all this data is useless to me. So without cataloging, it's like this is where the Inspire and the GeoCatalog and all their derivatives are coming in. So actually this is why, have you seen our GeoCatalog at the Esri? This is the one that we're really pushing very hard. I know I always put the Esri hat, I remember Jack Pace. But no, but I'm very serious. I'm very, very serious here. Actually, we do implementation of Inspire, and the Inspire is the European one. I know there's the Asian one have another one, and I know the Americans, we in the United States have another cataloging mechanism. But there's a GeoCatalog handles all of that stuff and more. If you can look at that, if you have some time, take a look at that. And I highly advocate NSDI infrastructure has that in there. And not only that, it's not just data, but also services. So this is very, very important. I have the data. Remember now, what I was telling you about, I cannot anymore bring this data downloaded. This is too big. Remember, this data is too big now in this data lake. So suddenly, because now I can bring programs to data, I can ingest that platform. This is not just a storage platform. This is storage and compute platform. So before we used to think only, okay, store data, I go to a URL, I download locally, I do in my little dinky environment whatever it is I want, and I'm done with it. And I can, it's ephemeral locally, I can remove it. Or if I produce derivative, I can share it back, right? Totally mind different set right now, ladies and gentlemen. What we're advocating is storage and compute. So now your geocataloging has to discover the data, what compute you can do on it. The compute, remember I keep talking about derivatives. The derivatives go back into the lake, cataloged in such a way other people can discover it. So you don't have this massive movement. And again, one of the things that we're advocating, which we talked about at the user conference, is this resource management that we're talking about, is now the compute that we have is also managed by the resources of the resources that are available are also managed by a manager, CPU, memory. So before you were only thinking of disk, to manage only disk. And right now, we're adding CPU and memory as a resource in this environment to be able to be managed. So when you execute on machines that has those CPUs, those machines on the data that's available to produce the derivatives that push things in there. So it's a new way of thinking. Very, very important. And you guys here, if you want to advocate that, don't just advocate the storage. I know I'm repeating myself, I'm sorry. Don't just advocate the storage, advocate the compute too. And the beauty about it is the compute does not have to be running all the time. This is an on-demand compute on the data. Actually, this is what, where's the judgment? This is what Roger is actually doing by the way, almost. You know? So we're seeing this more and more. And we at Esri are starting to take that. Actually, in 2017, you're going to see something new coming up from us that is actually really targeting this new angle, right? And so we have this kind of, if you think about it, there's this work group where actually you have this one person sitting on his machine, his or her machine discovering data. Then you have the work group people that are working together. And then you have the kind of, if you think about it, this community, bigger community where they're sharing a lot of these resources and contributing in and out to it. Okay? I want to talk to you guys about one more example that I love very much for something interesting, linear referencing. For the folks that don't know linear referencing, 5-minute quick tutorial on linear referencing. If you have a highway, this is the black area. What the federal highway and the local street people do is they basically break it up into mileposts, and those mileposts have different attributes associated with each one of them. So they take a long highway and they say, okay, I'm going to break it up into these mileposts, and between milepost 1 and milepost 2, there's different criteria. For example, what is the criteria is the type of asphalt that was placed at a particular time, right? There is another one is if it crosses over another pass, over an underpass, what's the height of the overpass on top of it? What's the number of lanes in a particular location? And you have all these different criteria. For the 2.5 million roads in the United States, there is about 100 attributes that they can associate with every mile between every segment. So they call these segments, by the way, and the reference between 2 mileposts that we want to do. So to do this, on the United States highway, they produce about 10 million, so we upload the data into Elastic. As you can see, I'm loving that Elastic animal in here. So for 10 million events for 1 year, by the way, if I want to, that's what they give me. They give me the year, the state, the route ID, the milepost 1, milepost 2, the key value that I need to do. If I want to take all this, I pass it through my parallel share nothing on my infrastructure. I put it in. It takes traditional way about a couple of hours to run. On my dinky Mac, 10 minutes. This new way. Pretty cool. But the best part about it, we can of course access it through ArcPy, which is awesome and can be visualized and do the whole thing. So, why I'm telling you the story is for smart cities. Okay, what does that have to do with smart cities? Well, actually, a lot of the time to spend on these data centers, we spend a lot of time on cooling data centers. Actually, Roger, where I was in Illinois, the supercomputer that they have up in Illinois in Champaign, they designed the whole building just to cool the machine that's in it. That's a whole, spend a lot of money on this. And so to be a good citizen to our cities and to the world, we end up looking around and said, is there a better way to do this? And I looked around at this company called Nordalizer. We'd say, you know what? We're going to push compute to the homes. Okay, we're going to make the homes smart. What do you mean by that, Mansour? What they've done is they've made the compute a heater. So rather than wasting the heat of the compute, let's use the heat as a heater in a house to do that. Isn't it awesome? Talk about carbon neutral and being smart about things. You're telling me what does Abu Dhabi that is doing dynamic segmentation that needs heat in their home? Actually, not true, ladies and gentlemen. This is a collaboration between a city up in the Netherlands, where these guys are residing, that needs the heat from the sensor that actually being executed by compute for Abu Dhabi. So these cities now are becoming smart with each other, being carbon neutral. Is that awesome? Is that neat? Is that like, this is how we need to start thinking, we as people. Okay, let's not waste resources. Let's use these resources for other purposes in here. Okay, so this money that I'm spending, yes, that supercomputer, yes, thank you, I think it's called Deep Waters and Roger and stuff like that. But this building here does not, if you think about it, well, you know what? We could have spent the money on this to come up with these things rather than wasting it all in one place. Yeah, okay, there's an issue of security. Of course, this all is secure and it's all interconnected, but we are in a connected world. Okay. Is that a cool idea? I love this. These are, sorry, this is so smart. This is so smart in here. And so we end up again throughout by normalize, bring it up, running the dynamic segmentation, and do some really interesting analytics. Of course, everything through a toolbox, and we can query different analytics and visualize all kind of data in here. Final one, before we take a final break here, I want to talk to you about what we're doing in Kuwait, which is talk about smart cities. So Kuwait, the PASI, the Public Authority for Civil Information, think about it as your Census Bureau, by the way. Think about it as the Census Bureau. They collect all kind of information. They have all kind of, they're very progressive. They hold about 14 terabyte worth of data, and they work with the government, with the building, with establishment, with people, everything is sitting right there. And one of the things that they work proactively to the citizen is they have an application on iPhone and iPad called Kuwait Finder. And Kuwait Finder gives them local hyper search capability for the environment that they're in. So this guy, the director here, was looking for a particular cream for his wife, literally, for her face, and literally he could use Kuwait Finder to find that in that store, in that location, in that corner, to be able to get exactly what you want. I mean, Google cannot give them that kind of hyper locality. Talk about smart cities, they're aggregating all this because the people are willing, the merchants are willing to give them that, because this is the central repository where they can get this highly indexed through the same engine that I showed you here to query that data, but now directly loaded from that. Of course, for that purpose, guess what they're doing? They're pushing out information out of it. So you can actually push out information out, and they can collect everything that you've been doing, part of the free things that you're using. So the collection GPS, what you're using, and they can do some interesting stuff. Believe it or not, the biggest thing that they do is routing, is from funeral home to funeral home. Because in the Muslim tradition, they bury the person the next day, and so you have to go pay your respect immediately. So one of the biggest things in the application is actually scheduling your visitation to funeral parlors to pay your respect. And of course, there's one for women, one for men, and you have to pay your respect for both of them. So they schedule that. Of course, growing problem in Kuwait is so the phone is a sensor. So one of the biggest problems of a growing city is what? Traffic in Kuwait is miserable. I don't know if you've been there, if you go even to Dubai, all these new cities, if you go to Singapore, all these big cities right now, traffic is a huge problem. For them right now, how they're managing all this information and pushing this information out for routing on the Kuwait Finder, they have to use here and Google to be able to get that information. And they have to pay these guys to get the money. So they said, well, you know what? It doesn't translate very well into Arabic. Can we eat our own dog food? They're like, what? You call me dog? I'm gonna... And calling dog somebody in Arabic is not very good, by the way. Okay? So they're like, a different joke. Okay, they're like, you know what? I lost my train of thought. Sorry, I'll come back to it. So they're like, can we use our own information to derive information that we need to feed back in? So remember, I keep telling you about, can we use big data as derivative for something else? So can we use a sensor as a traffic detector So I don't have to go to a third-party vendor, and I keep everything local to me. I don't have to go out to get additional information. And so we embarked on this project where each sensor is a phone, and we basically took out their existing infrastructure, which we had, which was SQL Server, by the way, was dying because they were plowing so much data in here that this SQL Server was not giving them what they needed. And so we first came in, and we literally, and the problem was, of course, if you had to add in more stuff, more external services, they could not break up from them. So we came in, and we literally, the Maher, the director came to me and says, okay, Mansour, I need not single one point of failure. Okay? Very, very important. This thing cannot fail. I still want to keep my SQL Server. See, remember? I do not displace in my SDI everything. I complement it with the new thing. So I keep things working, and then things get slowly migrated up. Okay? And I don't want to keep hiring this .NET programmer to keep on extending IIS. Okay, this is not working for me. Okay, every time I need to do something, I have to go to IIS, to my IIS developer, and build it. No more. I want to be able to read and write very, very quickly. And of course, very, very important today, log everything. Nothing needs to be thrown out. Okay? And of course, I want to do analytics on demand very quickly because that's what we're going after in here. So we sketched it out on the board. We always start with something nice like that. Okay, this is what we need. We need this animal, we need these animals, that's what we need to do. And I'm going to talk to you guys a little bit on detail. So the first thing we do is we brought which is basically holds the state of all the machines, times 3 machines for resilience. Okay, next thing. We were able to, so Zookeeper is to maintain all the distributed compute. It's highly available and has a very simple API to manage. And the biggest thing is distributed configuration environment. Next thing we brought in is we took out and we brought in Kafka. Kafka is the basis for everything, is a message bus. It enables us to pass millions of events per second on the infrastructure in here. So we hooked up, rather than connecting directly to SQL Server, we hooked it up to Kafka. So Kafka is a message broker for high available, low latency, and distributed. Again, no single point of failure. People publish on a topic. If you notice, there's no direct connection between the publisher and the subscriber. If you need to do something, you create a message, you send it on a topic, it puts there. If there's a subscriber that comes in, picks it up from the topic. So now nothing gets lost. Everything that anybody, there's nobody talks to anybody, which is this intermesh. Everybody talks to a middle tier, the middle tier breaks it up. And this is fully resilient to failure because of the Zookeeper that was available out there. Next thing, of course, we brought in our first search engine, like what we showed you about. Remember the 2 million record, 300 million? Instead of storing it in SQL Server, we brought in a new data lake engine to come in to really for that purpose. I did not throw everything out away, I complemented it. Again, the SDI infrastructure is extended, not replaced. Very, very important in there. Okay. And again, distributed, share nothing, resilient to failure, and HTTP protocol and store JSON documents. And the resiliency to failure is if you have a document, it's broken down into small pieces, and every single little piece is explicitly shared on multiple machines. So a machine, if it falls down, the intern that's replacing this thing, guess what? Hey, I can wait 2 days if God forbid, because guess what? This always happens on a Thursday afternoon, which is in Kuwait is basically is the weekend. So the guys are not going to come in on Friday, Saturday. They have to wait to Sunday to come in. So I have a full 2 days, to come in and plug in a brand new machine, because everything is available on the other 2 machines. And guess what? It happened the day I left. Son of a gun. I left on Thursday night. I called up the morning, called up Maher, what's going on? He's like, Mansour, your aura went with you. One of the machine died. Of course, it was a bad disk, no problem. He says, we'll fix it on Monday, we'll fix it on Sunday. Don't worry, be happy, travel safely. Love you. Okay. In a professional way, of course. And then we replaced the connector between the Logstash with this animal called Logstash, which enabled us to read data from Kafka, dump it into 2 places all at once. So again, there's no direct connection between everything. And so once we did all that, we were able to write up the code. I know, don't freak out, but a very simple configuration. Anybody can write this type of configuration. It's just simple connecting one end to the other one. And we're up and running. Okay? And then we did some deep analytics using Spark. Spark is our new way to process data. and it's a compute engine to do in-memory, high in-memory processing, and one of the best things about it, you can program it in Python. So you keep hearing me talk about Python. Python is the language to use for the future, ladies and gentlemen. For the kids in the room that want to learn something, invest in it, okay? And even for the old folks, okay? I'm not calling you old, I'm just calling you wise, okay? And then finally, we were able to write some very smart snapping. This is where Smart City comes in to do very intelligent snapping. So it's, again, we don't just take a point and based on a radius search, we snap to the closest distance. We have to exactly find out, we don't just, we have to do it smartly. It's not just because it's close to the particular edge here, we have to take the direction of the street to snap it very, very smartly, you see? So these are the kind of stuff that, this is just a basic smart intelligence that you have to do for the data. Okay? And once we did all that, we hooked it up all together, and we were able to then publish data and visualize and do some pretty cool stuff. So that was a pretty neat project. I'm going back in October, in a couple of weeks actually, and we're going to take this to the next level. We're going to start bringing machine learning and starting to do predictive analytics and all this data that we've been accumulating. One of the things that we did not know when we started this, what it was the impedance on the roads, what the weight of the roads were going to be. Okay, that was a big problem that we started, and we did it literally. I think the weight need to be so much, and that was like totally stupid. And we know this. And we knew this. That was like, okay, we think this is, we started with some empirical value, and we came up with the weights. We came back actually, before he came down, we came back, and we've been accumulating data. Remember, we logged everything. We went back, we reanalyzed the data, and we came up now with the correct weights. And we compared it to Google and to really good things, when we compared it to here, which is, they have their own feeds and stuff like that, we were smack on the money. So talk about government to government itself, feeding on itself, really working very, very well. And so now what they want to do now, to push this out, G2B is picking it. Because now the local telecommunication want this type of information. Okay? And we want to work with the local businesses. So we want to work with the Zains and the Oridos. These are the telecom. These are the just want to start feeding back and forth to each other. So we want to give them data, and we want something back in return. Not we. I mean, PASI, the government, want to work with the local government, with the local businesses, in such a way that they can give them information, but at the same time, hey, by the way, you're getting something from me. I want something from you. So B2G. Okay? So this loop, staying within. Increasing the value of the local government and the local places is so important. And now business and government can work very well together. And this is a beautiful example here of that. Beautiful example from that happening. Okay, ladies and gentlemen, I think we're up to 2:50. We're almost at the end of the talk here, but we can talk more. I'm sitting here. Let's take another break, and if you want
we can have discussion, because I know some people are interested.
I know.
In case any question, discussion, we can have this, and then of course we'll be around. And after that, actually from 4 to 6, we are going to actually party in what's the name? Bourbon Street, Indiana Street, I
have one more road ahead, but it's up to you guys if you want to see it.
Let's open this for questions.
Yeah, let's talk about this question, and if you want to stay, I can talk more. Literally, as you can tell, I can talk all day about this stuff. I have no problem, but I know your time is precious, and I really, really appreciate it. So I'll open up for discussion, and then we'll go from there. Yes, sir.
Go back to the Kuwait example.
So why do you think the issue so also I don't know who it's to.
I'm Phil Worrell, I'm the Executive Director of the Indiana Geographic Information Council.
Right.
We're a nonprofit members organization, so a lot of folks in the room here are, I work for them. But we are education, outreach, and we also host what's called Indiana Map,
right,
which is our basic data warehouse and clearinghouse for GIS data, public GIS data. So the question I had about the Kuwait thing was, why did they reinvent the wheel? Why didn't they just use Google?
No. They were using here. They are using here. Actually, this application here, this one, was using here.
Okay.
They have to pay here for the data.
Okay. All right.
That is the problem.
Yeah,
And it's a lot of money.
Yeah, I know.
It's
You
a
got-
lot of money that you have to pay for this. And that's one of the things is, can we save money by using our sensors to derive this data? And that's the whole key thing that he's talking about is this bridge. I was talking about derivatives. How do I take this data that I have a lot of, derive it into something new? And this was an experiment that we did about a year ago and turned out like, oh, this is, so we did it as a POC. You know, we spent 1 week doing the POC, then I came back and we did it for real. And so, can we take big data, derive from it something totally, two separate things, come up one from the other one.
Right.
And it was math. It was literally math. So if there's one thing else that is in big data space, ladies and gentlemen, is math. So, stay in school.
I'm 100% on board with that concept.
Right.
Because with Indiana map, we have, state, we have counties
Right.
producing street center lines
Right.
and point addresses and jurisdictional boundaries, and that data is very, when it can get aggregated to a state level,
Right.
it can serve many, build once, use many times.
Not only that, he, Maher, the director, is very good at the scheduling of the updates. He has better data than Google and Yahoo and everybody else because it's his own local data. He's the one that is talking to all the agencies. Give me this, make sure it's updated. He has collectors going out in the field getting data. So he has better data as base map than any of those guys. It's like, why don't I use that? I invested in this, let me use it. And so he set up that infrastructure, complemented with this new thing in here. Suddenly he has better insight, no pun intended. And that's what literally it was after all. And that was that loop stays within them. I don't want to go outside to depend on anybody. I can create my own data. And not only that, it's not just for me, but I can share it with my community too.
Perfect.
Do you have any other questions? So, what I suggest here for the sake of, are you videoing all the way to the end?
What?
We still are doing the video thing?
Yeah.
Perfect. Okay. So why don't you do this and then we can comment quickly and link this to the big, smart city thing and then we
Okay,
can conclude and then we can part
it's actually for the gentleman here to see what's going on here. I'll make it quick. How's that? I know your time is precious, ladies and gentlemen. I'll make it quick and we'll tell you what we're working on at Esri. So for me, as we can see, the Internet of Things is IoT and real-time starting. I mean, it's been around for a long time, and we're investing basically in a lot of these things, these fundamental things. We're working with a lot of the streaming Internet of Things it's a big double quote. And of course, machine learning is one of my favorite topics. That's what's keeping me up at night right now. It's like, I love it. This is what is very exciting, and I think it's really amazing. And so we're starting to do beyond batch analytics. It's not anymore batch. Now we're starting to do streaming. And we're talking to these are the technologies that we've seen, that we've been fooling around with, and we've been experimenting with to bring in the type of data into the equation. And of course, in machine learning, we're starting to do the unsupervised, supervised. The first one that, of course, is the supervision one, which is easy because we have existing data, we know what it looks like. And so now we can start training these models. The biggest thing for me is these regression models. They're becoming so big with so many number of parameters, I cannot come up with the weights of those regression models. I can let it figure it out for me. And we've had some very good experiments right now, like what was telling me yesterday in DC, where we're starting to do some really good, interesting, deep model analytics and let the machine figure out the weights for me to come up with these regression models. Some very, very cool stuff. Of course, Internet of Things is ubiquitous, as I was telling you about, and of course, city IoT. So, city IoT is like what's hit. I don't know if you've seen LA Hub. This is something that we talked about at our user conference. It's they're pushing in one, LA is starting to push in one portal all the information to be disseminated out to the community. If you want to look about it, I can send you some link about the LA Smart City Hub that we talked about at the user conference. We have a video about it that I can send you guys a link of. And when it comes down to data, we're starting to fill around with not only points and not only with point size and polygons, but of course raster. It's the fusion of the two together that's making it very powerful now. So you don't just work with one domain, you work with two domains. Again, I love to give the deforestation project, which is was telling you, I have for every 30 meter, the deforestation pixel, right? But I can combine it with distance to road, distance to mill, to influence that regression model. So now you're combining raster and vector together to come up with better scenario. Typically, you work with one or the other one. This fusion of the two together is making things so good. And of course, my favorite, vector tiles. I don't know if the gentleman that spoke before me was talking about that. Boundless people. Yeah, but vector tiling is the best way to start representing massive data on the client side. This is, ladies and gentlemen, what I call cooperative processing. There is a CPU on the server, right? There is a CPU and GPU on the client. Let me take advantage of both of them to give me what I call an expressive experience. So before, back in the RKMS days, I remember I wrote RKMS. On the server, I was producing images, sending everything down to the client because they were done. Now I have CPU, and GPU here. Let both of the edges work together to give me the expressiveness that I want in here. Okay? And with the advent of HTML5 and WebGL on the client side, and even on these little dinky things, I can have a better experience, 3D, 2D, and all those. Okay? So we're pushing big raster images, and we're pushing the RGS platform, of course, to fuse it with RGS Online. And you can push up all your base maps and push out demographics through RGS Online to be reflected. Again, the streaming, name it. Twitter, Instagram, Facebook, RSS, get data from static gauges, people, from different sensors, from, of course, the military goes without saying. We can push all this through Geo Event Processor. Sorry, the page is not looking good here. I need to fix that. We have our own processors when we bring in the data. They can do, like for example, we're using it to track parolee from prison. If the parolee exceeds the geofence area, guess what? An alarm goes out. Actually, we're using that right now in California to do that. And if there's one that does not exist, you can build your own processor for this scenario in here. Like what you saw, this is an extension to the desktop, to Pro. In the Pro, you're going to have a brand new toolbox in such a way that you can do these big analytics in here. And so we can start taking advantage automatically of Spark and Elastic. By the way, this is going to be built in automatically, those engines, those new engines that I keep telling you about, they're going to be built in into the RGS platform in such a way that you can just go into the toolbox, execute them, and get these analytics in there. My favorite ones are these guys in here, hotspot, density calculation, and nearby. We're taking all these algorithms from our toolbox and we're making them parallel, share nothing, distributed. Now, we're not taking the 300 tools that we have, we're just taking some of them that you guys use 80% of the time. These are the 20% tools that you guys use 80% of the time that are hard. Okay? And we're doing that here. Okay? And of course, we're doing space and time with them, which is pretty cool. And actually, this is where I want to show you a beautiful demo on spatial joining. So before I let you go, I have one more video, ladies and gentlemen, to show you, which is how we did spatial joining on billion by billion records.
One common type of big data is spatiotemporal event information. For example, this data set contains 1 billion financial transactions across the US. And the problem with this kind of data is that to visualize it, you have to wait, and wait, and wait, and see if it ever stops drawing. And you can't find patterns in information this way. To find meaning in these kinds of huge data sets, the first thing to do is a simple aggregation. So how did we aggregate 1 billion financial transactions? We've been working to enhance ArcGIS with capabilities for batch analysis on these kinds of huge data sets. GeoAnalytics will be a new server capability that lets you run spatial analysis as distributed computations across a cluster of machines. The GeoAnalytics tools are geared to help you understand your data. You'll be able to find hotspots, run buffers, and summarize your data to explore patterns. You'll be able to aggregate your data by regular bins, such as, in this case, we're looking at the raw count of transactions. Or you can run densities to see distributions in your data. In this case, we're looking at the density by the amount of money, so we can see which areas are associated with larger transactions. And you can also aggregate by any polygon, so that you can normalize by population and begin to understand where patterns are different than what you might expect. In this case, we aggregated the billion records by the 74,000 census tracts in the US. The GeoAnalytics tools can operate across a cluster of machines, which means that you can run bigger jobs than ever before. Now, exploring patterns is an important first step in understanding your data. But in these mountains of information, often what you're looking for is a needle in the haystack, the activity that actually differs from the normal pattern. In the case of financial data, often what we're looking for is waste, fraud, and abuse. So what does fraud look like? Let's check out an example of how money laundering can play out in the real world. One technique that criminals use to move large sums of money around is to spread it out over multiple transactions. So one or maybe a few people will quickly visit several financial institutions and send transfers that are all below the legal reporting threshold. Some of you have domain expertise like this, but many of you want to understand the important and abnormal activity in your data. The challenge is how you query for that. How do you teach a system to detect that? If you were going to query for this money laundering behavior, for example, there's all kinds of variables. For each transaction, you'd have to consider the distance to nearby events, the amount of time between them, the amount of money involved, and then the recipients at the other end. And then you have to do it all 1 billion times. You'll be able to use the new tools in GeoAnalytics to ask these kinds of complex space-time questions. For example, the Join Features tool lets you find associations between features based on attributes, based on spatial relationships like these, and based on temporal relationships, and all three of these at the same time. This is multiple dimensions of relationship analysis, and it's never been possible before at this level of space-time detail. We used Join Features to mine all billion financial transactions for this fraudulent behavior. So let's see how that works. The GeoAnalytics tools work with your data. You'll be able to use them with traditional geospatial formats, and you can also attach your big data to ArcGIS as file shares. Now, to query for this money laundering behavior, we focused on the starting locations of these transfers, and we joined them against themselves. So for every single transaction, we asked how many others took place within a kilometer and an hour of it that were all going to the same recipient. And the tools let you run summary statistics on any of your input fields. So we summarized the amount of money involved in each grouping and used that to refine the results. Using a cluster of 20 nodes, we ran this billion feature join in 48 minutes. 48 minutes to burn down that haystack. Thank you. 48 minutes to burn down that haystack and find all of the potential needles within it. And what we're left with are just those bursts of activity from a small area that all went to the same recipient in a different location. And then we can use the amount of money and the number of transactions to isolate the most suspicious behavior. GeoAnalytics will bring the power of distributed processing to your vector big data and open up new ways to examine your information across space, time, and signal for heightened understanding and awareness. The patterns and trends that you discover with these tools can then be automated to raise indications and even alerts when important activity happens. We can't wait to see how you apply these tools to the questions you never thought you could answer.
Cool. Yeah. 1 billion spatial join in 40 minutes. Okay, I had 20 nodes. This is what I was telling you about. Your SDI infrastructure is not just going to provide storage, but it's going to give compute also for somebody can come in, allocate those resources, executing on them, such a way you did them, everybody, like Suzanne, was so easy for her to just go to the toolbox, push here, do it, run the analytics, get that insight. That is I believe, is going to be your next SDI for you to be good citizens to whatever it is that you provide. And giving insight to your cities, fusing it from all these places, merge them together and produce the result. Okay? And then we're working on these things to help you do these things. Plus there's more that we can talk more about. I mean, I can talk, there's a whole separate topic. Yes, sir.
Quick question about how that works. So if I have an Amazon cluster and I have Cumulo or an HDFS up there, in the future with Esri, I would be able to connect to my cluster.
Yes, register your data source, register your compute, take that analytics that Suzanne ran it up there on that instance, cloud with the data, put it up there, visualize.
And I would just add, AWS has a year free trial subscription. That's a great way to get your feet wet.
Yeah, you guys have to figure this out. That will become your new SDI infrastructure that you guys may be gonna. And by the way, we're agnostic. You want to end up doing it on Azure, Microsoft versus AWS, or you build your own data center like what Roger is doing in Illinois that you can deploy on it. We're like what, for example, I'm sure Abu Dhabi will want to do the same thing because they have the money, or Singapore, they have the infrastructure to do that kind of stuff. So yes, we are independent. We have the foundation right now because that foundation is already democratized. Between you and me, it's called Mesos, by the way, FYI. Okay. It's available, okay? Now we just focus on bringing value. That's it. Okay. Yes, sir.
Mansour, I have a business proposition. First of all, you make my network. Thank you. But I have a business proposition for you. I would like to work with you to start a new cell phone company.
Okay.
We're going to give away self-service free.
Yeah.
Because that's peanuts.
Yes.
But we're going to sell the derivative products through a liberal user agreement to be able to mine that.
That's what they're doing right now. Yeah, literally. That's like the scenario that I'm giving you, Jim, are not foreign. This is not foreign. This is not Mansour talking, what's his name, out of his, mouth. This is really.
Well, a live personal example. So I go every morning, I open my BBC to check what's the news. Like I don't trust CNN, so I go to BBC always. And all of a sudden I have this ad on the right, date, a single Arab woman. And I thought, heck, how do you know that I'm Arab, I'm single, and I'm trying to date somebody? Apparently now I learned the story, now I know the secret. Now we know. Anyway, well, thank you so much, Mansour. This is very rich presentation, lecture, lots of technical information I know, but it's important. And just to back up, put this in the big context, what we're talking about smart cities. The whole idea of smart cities is about Internet of Things, how devices connect to each other. And with the connection of devices, there's a lot of flow of information, flow of data, how to handle this data, where to store the data, economics of this data. So what Mansour has given us today is just, open a lot of, interesting ideas for us, understanding of, okay, just, to talk about smart cities, smart technology, smart environment, smart buildings, we have to talk about what data about this smart state, how devices interact, and this data need to be handled, need to be stored, need to be queried, need to be processed. This is what he's talking about today. He just opened our eyes to a lot of new things, which thank you so much for that. We appreciate for that. We still have a lot of stuff to talk about, other issues related to smart technology, besides the data, but just the data itself. It's just, you can see and from things that we need to understand. And I hope basically with this open ideas of Indiana Map, how we upgrade, think strategically about Indiana Map in terms of providing services, not only data, and that's it, services, how we handle the data, different layers of processing, and that is another thing. So thank you so much. Mansour is still here with us, and we're still here until 6 p.m. So you guys can ask questions, talk to him, but let's thank him in this question. Thank you.